Alright, class. What we're going to talk about today is finding rational roots of polynomial equations. And with finding these rational roots, well, you know, as you've seen, some of them are going to be quite difficult. They're not the quadratics anymore. It's going to be kind of tough to figure out, okay, where it's going to be intersecting 0, where the number is going to be, working out in our favor. So to give you an example, I'm going to start with x cubed plus x squared minus 3x minus 3 equals 0. Now when we talk about finding roots, what we mean is what values of x are going to make this statement true. Now, if you look at it, there could be multiple values. As we talked about in class before, when you have a cubic function, that means there's a possibility of having 3 roots. But we've seen some examples before where the graph might not exactly go through the line 3 times. Take a look at this example, for example. We get this one here, where all of a sudden it's not going through 0 because it's going through its minimum above the x-axis. And when that happens, we only have one real root. Well, I'm going to be honest with you. This example here today is going to be just like that. We're only going to have one root in this entire section. So let's get rid of this for now. Now, you'll notice that this example here is in standard form. This is how you're going to want to do this, because in order to find the rational roots, we're going to test some values, and they have to deal with the leading coefficient, which happens to be this cool looking number right here, and it's also going to test with the constant variable. What we need to do to be able to find this value is basically choose a value for x that's going to be a factor of our constant and a factor of our leading coefficient. So if you look at that, we've got a factor of -3 divided by a factor of 1. Well, because there's a few options. Some of them are obvious, some of them are not obvious. Our factors of 3 and our factors of -1, when we do this out, are going to be plus or minus 3, and it's going to be plus or minus 1. When we divide it out, we're going to have positive 3, -3, positive 1, -1. So, these are the only possible rational roots for this equation. Let's bring this over. Now, when you have those values, what you want to do is test each one of those out. I know it seems like a plug and chug experiment, but that's kind of what it is. So I'm going to start by testing our first value, test number 1. Not only is it test number 1, but we're also testing for the value of 1. What you're going to do is plug in 1 for all your x values there. So it's going to say 1 cubed plus 1 squared minus 3 times 1 minus 3 equals 0. I'm going to say, okay, 1 cubed is coincidentally 1, plus 1 squared, which is also 1, minus 3 times 1, which is -3, minus 3, which equals 0. 1 plus 1 becomes 2. 2 minus 3 minus 3. I'm going to get an answer of what seems to be 2 minus 3 is -1. -1 minus 3 is -4. And you're going to look at that and say, okay, -4, does it equal 0? No. We can cross that off, which means that this test happened to fail. 1 is not a rational root of this example. Well, once you're done with that one, guess what? We get to try it again. Now let's take our next possible answer. So we're going to say test 3. Because I don't really feel like writing it again. Oh, look, there it is. So, now I'm going to test 3 with all these numbers here. So I'm going to say 3 cubed plus 3 squared minus 3 times 3 minus 3. It's a lot of 3's. Don't get too distraught from them all. So 3 cubed is 27 plus 9 minus 9 minus 3 is equal to 0. And with some simplification, we can already see that the 9's are gone. So 27 minus 3, I'm going to get an answer of 24, which does not equal 0. So this here also fails. Let's go to our next one. Let's test -1. And yes, -1 is a different factor than regular 1 because it can also yield different results. You may not think so because of these exponents up here, but they actually do change with negative numbers. For instance, when I do -1 cubed, that's going to be -1, not a positive 1. -1 squared, however, becomes a 1. -3 times -1 plus 3 minus 3 equals 0. And through the brilliant laws of mathematics, if we look at this, those cancel out, those cancel out. I get an answer of what happens to be 0 equals 0. And luckily with mathematics, that means that we pass. In fact, -1 is an actual root of this function. Now, I know I told you in the beginning that there is only one answer for this, but had there not been one answer, we would have to do this one more time. So because I am the math teacher and I do like to do as much math as possible, we're going to do this one last time to make sure that everything is correct. Except now we're going to choose the last variable, which happens to be a test for -3. -3 cubed plus -3 squared minus 3 times -3 minus 3 equals 0. Multiply it out, -27, forgive the mimeo there, plus 9 plus 9 minus 3 equals 0. So when I do -27 plus 9, that's going to be -9 minus 3 equals 0. I get an answer of -12 equals 0. Unfortunately, that is not true, or fortunately for us. So this fails. And that is your example for how to solve for polynomial roots that are real and rational